Hello everyone, today I will present to you about our paper, namely NAYER, Noisy Layer Data Generation for Efficient and Effective Data-Free Knowledge Distillation. First of all, let I introduce you about some background information. Let's start with knowledge distillation. It is very popular technique which was first mentioned by Hinton et al. And currently have a lot of application. Given the pre-trained teacher model and training set, the aim of this method is to transfer knowledge of the pre-trained teacher model to the student one. Please note that, in this setting both student and teacher can access to training set. However, in real-world application, there are several methods which contain the private information such as hospitals' patient information or customer-sensitive dataset. From that, this raises the need of data-free knowledge distillation. In that, only given the pre-trained teacher model, how we can transfer knowledge from teacher to student without accessing training set. There are several methods proposed to address this problem, however almost of them uses the input of random noise, Z, and generate the synthesized images. Firstly, they train the generator to synthesize data which need to contain two main properties, the similarity and diversity. After that, they use the synthetic data to train student model to mimic the performance of teacher one. However, the existing methods demand extensive training time and often produce low-quality data. Here is some example of synthetic data from current SOTA. It is clear that almost of them is no meaning noise. In case of training time, they require 10 to 20 hours for small-scale dataset and almost cannot work in large-scale dataset such as ImageNet. There are two main problems. Firstly, current method uses the less meaningful random noise, Z, as input, slows down data generation in the model and limit the data quality. Secondly, they use the input level random source is weaker and limits the diversity of data generation. To address them, we propose to use more meaningful label text embedding E_Y as input. As you can see, since LTE contains the interclass information, it makes generator easier to mimic the ground truth distribution. However, while LTE helps efficiently generate high-quality data but decreases the diversity of these data. The noisy layer Z plays a key role in addressing this issue by preventing the model from overemphasizing the constrained label information and its stronger random source. So, here is our proposed methods. Firstly, NAYER uses the text encoder C to create LTEs, which are stored in the memory pool P for training. After that, we use LTEs as input for Z and G to generate synthetic data efficiently. We also randomly reinitialize Z for each batch to generate diverse samples. Here is the experiment result of our method in several dataset from small to large scale. All of them demonstrate that our method have a better performance compared to SOTA methods. This chart furthermore demonstrate that our method not only have a higher accuracy but also 5 to 15 times faster than current methods. Here is some synthetic data of our method in ImageNet. In the bottom row, we also compare the synthetic data of our method in CVPR 10. It is demonstrated that our synthetic data have more meaningful information compared to other methods. Finally, thank you for your watching.